title of the talk is Binary and Ternary Structures in Evolution Theory. This is part 5, and we will introduce entropic description of the evolution of the universe. This is open discussions. You see, now this research in progress, just beginning, and so we can present only sketches of our direction of studies. One of the organizer pushed me to open, so I will do it. Yeah. This present several basic problems on the cosmology which are not solved and discuss them. I think new unexpected ideas are wanted. So we give naive questions in the cosmology. Naive question is why cosmology should be described in terms of physics? If we say study the cosmology, then without saying physics, with physics we should describe, yeah. But next question comes, can we describe the evolution of life things in cosmology? So it is not necessarily include life things, but for me, life thing is one of the most important results of the evolution of the universe. So we have to include them. Yeah? Also, can we describe the evolution of language and cosmology? Oh, this is also same reason. Without language, we cannot describe cosmology. So uh, now we need the total, we have to answer at least the direction, including these topics. So can you answer these questions totally? This is a naive question. Huh? Okay, then there exists a theory which answers these questions totally. Oh, Suzuki, what are you doing? What are you saying? You are too old now to Alzheimer and crazy man, no? But no, the entropic method for cosmology is possible. I want to say that. Okay, then this is a good news. Is Professor Barinde has introduced a concept of entropic gravity or emergent gravity, and derives the law of gravity and the Einstein equation from it. This is quoted from YouTube, so I'm afraid this quotation is correct or not. If so, then do we need not insist on physics? Huh? So that this idea pushed me to make a talks here. Okay, the lecture is divided into 3 sections. An entropic method for general evolution theory, section 1, and non-commutative Galois theory for an evolution. I think participants know the non-commutative Galois theory, but I'm not sure. But this is even a mathematician, there's a special topic. So I will introduce it. This is very important for description of hierarchy structure evolution. So finally, if I have a time, application to the evolution of the universe, the problems, yeah. Important is 1, 2, and 3, if we have a time, I go with 3. And to pick the general evolution. At first, we general evolution theory. In this session, we propose a concept of entropy and describe general evolution theory in terms of entropy. Oh, then I have started from the very elementary knowledge. I have never written a paper concerning entropy. Professor Duda's entropy is a very, very varieties and many kinds, but my definition is very primitive. Entropy is a logarithm of the number of cases or combination. How many passes from P, Q to minimum pass on lattice pass, then calculating the 70, and its entropy is log 70 in this way. So then here I will talk what's the role of entropy in the evolution. This is the key point of my discussion is section 1. Then the role of entropy in evolution. When the structure is structure constructing, then the entropy becomes smaller. For example, plasma of molecules we makes polymer, then structure is constructed here and the entropy decreasing. And the structure destruction, the entropy of the increasing. For example, so bomb is coming and then bam, explosion, then entropy of the system increases. This is the increasing of the entropy is Boltzmann entropy. This construction and the decreasing the entropy we call Schrödinger Bergman entropy. Schrödinger is, has talks about this entropy, negative entropy. Bergman always says evolution is against Boltzmann law. Boltzmann law flow us from the high temperature place, lower temperature, but life things and other evolution is against this process. This is so only with this basic notation, then we will discuss evolution. This is the main purpose of this. Then how can we describe evolution in terms of entropies? Here, at first, here we say the entropic description of evolution, general evolution. We assume that every time the evolution is begin with explosion. For example, the flowers are making plants making the flower and spread seeds. Then that is explosion and situation, and increasing that's the Boltzmann law. And also in the case of as of birth of universe, also Big Bang and the masses are spread in this universe, and Einstein's cosmological constant effect contribution to this entropy. Then soon later, structure is created. As I've told, the plasma of polynomials, then polymers are created, then entropy is decreasing, and then if then stops, then Boltzmann principle does not hold. So some other additional entropy is added and keeping the Boltzmann entropy increasing. This is called the supplementary entropy. In the case of molecular biology, also this is this is also origin of the life things, but that is unclear. So we imagine the evolution of life things. Then nucleotoid is spreaded, and then RNA or DNA, proteins are created. So at the same time, if we look carefully, then in DNA, RNA, and in proteins, there are so many junks. Junks means how these can create it. These do not contribute to create rigid protein and others. But that is very important. Even in the case of language, as intelligence of language ability spread, creates the words, yeah. This is oh, yes, hello, and etc. And then evolution started, and following Chomsky, we can create the sentences. But in this case, also Chomsky stops this level, but after this, we must prepare this junk, because junk sentences are not a logical one. Huh? For example, agitation demonstrator says, rich people is a dog, or rich people are pigs. Oh, this is logically no, this is the true sentence, but this in the agitation and others, this is important. This is such a nonsense sentence will survive in the future, and so that new sentences. So this is very important. This, so we please don't forget this contribution. And then repetition. This process is called cycle or period. One period here. Huh? So this is the next step in the further repetition of period evolution describes the total and the finish. Then once again comes, then structure is created, and junk or supplementary entropy is created and keeps Bergman, no, Boltzmann principles. Okay. Oh, here I will skip here later. Yeah, it is a supplementary entropy. We make a comment. When baryons are constructed, leptons and gluons are emitted. I think that that can be counted into supplementary entropy. Also, dark matter is constructed, then dark energy emitted. That is it is natural to consider that as a supplementary entropy. In the protein, as I have told, the protein sequence, so many junks observed. Yeah. Okay, then this is a picture of the evolution of universe. This is taken from Short History of the Universe. I like this book very much, and here Big Bang size is very small, and then inflation and extension, and here is a quark and baryon and atoms and galaxies. Now you come here. Huh? Here also live things or polymers, and very, very recently. Then the main problem is how can we decompose the total evolution into successive period of evolutions. So if we have no methods, then periods, concept of periods is nonsense. But division can be obtained by hierarchy structure of an evolution. Huh? This can be performed by this can be done by non-commutative Galois theory. Huh? Then I think this is a very new idea. No? Then how can we describe numerical quantities of evolution? If I say the periods, evolutions, and successive procession and the total evolution can be given, but if we cannot give a numerical quantity, then almost nothing. The strong point of physics can give the detailed quantities, for example, Einstein equation and other, that can give the clear quantity and based on observable observations, satellite and others. Yeah. Here is analytic quantity and algebraic quantities divided into two. The first one is Jeans duality. Now, and later I will talk about the BTBB structure. Huh? Okay, then the Jeans duality. Then we have the basic relation which is called the Jeans duality. Then, as I have told, then at first Big Bang explosion, evolutionary entropy comes. Then structure is created. That's a minus. Huh? The total is a negative entropy, but there's I will count entropy is positive, so minus. And then supplementary entropy comes. Then that is a total Boltzmann entropy. That is called the Jeans duality. Then duality. Duality implies this is creation. This is creation, but this is destroying, deconstruction. And total sum is controlled by the Boltzmann principle, entropy. The idea of the Jeans duality evolution, Jeans duality falls for the conflict between structure constructing, structure deconstructing, and the competitions, and the total sum is governed by the money, spending money, sparing money. Then the Boltzmann, Mama Boltzmann comes, oh, you must pay in this way, or so on. Yeah. Then remark one is omitted. So we may expect Jeans duality derives the original Jeans equality, which determines the size of stars. Because of this, I call this Jeans duality. And star is very hot and look like some magma, and they want to pressures and to extensions. But gravitational power is attractions, and then stability between these competitions. Then the genes determine the size of stars. So, yeah, this is very important. If this remark 3 is true, then almost our dreams and going to construct new mathematics evolution. But I think I'm afraid this is still not okay. It's very important for me. Thus, the Jeans duality derives the Einstein equation in the evolution of universe. Irlander has introduced the concept entropic gravity and derives the law of gravity Newton and Einstein equation from it. So if it is true, then okay, but it is not, still not, then we may expect to derive his results from our Jeans duality. That is maybe a possibility. dream. If assumption true, then we may derive other quantity in physics. For examples, you see, gravity is two matters. What do you say? Nearer is repressive, but charge also same character. Electrodynamics, plus minus charge, then speaking coming. If same charge, then out. So I want to make stress that the potential curve of Newtonian gravity and charge of in electrodynamics the same form. Is that the reason? I think Professor Duda has can answer this question, maybe no. Or also biology, we have some attractive male and females. Each other is nearer. And also language also verb come, subject come and verb come. They each other attracts. But subject, then these are not comes nearer. I think the measure of such a length is can be measured by Shannon entropy. So if can success this, then we for a moment forget the physics and we describe everything in terms of entropy, and then we will make a new mathematics. Yeah, mathematics evolution. Oh, suspicious? I don't know. I will try it. Okay. Now, this is a entropic description of evolutions, general evolution. Now, next we're going to non-commutative Galois theory of evolution. Okay, a little bit here. We begin with the evolutions of examples of BT-BB structure. What is BT-BB structure? I will explain soon. Then origin of universe is a big bang or inflation. Then photon created. I think photon is simple random walks, and then binary extension is a photon creates quark and anti-quark. It's the two kinds of separation is called the binary extension. And then quark comes, then quark has ternary extension appears, and three colors, yeah? Three colors, quark, anti-quark. That three number comes. This is called the ternary extension. Then the successive binary extension, the quark is a top quark. Here is B quark, C quark. T quark is divided into, extended to C quark, S quark, and B quark into U quark, D quark. This process is binary. So this is called binary at first, ternary extension, and binary. Huh? Binary. Huh? Binary. So this is called the BT-BB structure. Also in molecular biology, also this is the origin of life, explosion of the RNA created in this world. And the RNA created the DNA. DNA has a dual structure. They make coils. And duality is D, A, T, G, U, or so on. And the ternary extension comes, then UUT, codon table. Three triples make a protein. Huh? Oh, that is why 3 comes. That is a very mysterious thing. Yeah. Then successful binary extension, in this case, mutation, insertion, or there are many binary operation exist. So how can we associate? That is a problem. Anyway, we can also BB structure. Hence, we see that binary structure, binary ternary extension, binary BTBB structure. Okay, next we are coming to formal language theory. This is the ability of language, the origin of the language ability. That is quite mysterious, but we may assume that the inside almost unclear. Then finite automaton language, then sequence words. Sequence words are already used by birds and animals, and etc. And then binary extension comes. That's a Chomsky sentence. Context-free language is non-ending parts, subject and etc. And ending verb. Then ternary extension comes. Context-sensitive language. This is for unclear object, but there exists ternary creation of language. Chomsky has considered at the beginning context-sensitive language, context-free language, and context-sensitive language, binary ternary, but later he omitted this, only context-free language. And successfully binary extensions, then Turing machine comes, and full Turing machine and the general Turing machine, that is full. Also here, you can find the binary, ternary, binary, much more. So we can observe the BTBB structure in, that's a phenomenology. But here, look, mathematics. This is not phenomenologically, just theoretically one. Here, the beginning of the origin of mathematics. Explosion, and rational number. Here, what kind of complex number or so simplistic sake, we choose the rational number. Then but rational number is very quite natural, and integer and division, and then cake division and etc. Rational number comes. And here we take an algebraic equation, fx equals 0. Every coefficient of f is a rational number. Then in order to get the solution of the algebraic equation, at first we must add the root determinant of the polynomial. There's a binary extension. Okay. Then next ternary extension comes. Some combination of third root, that is called the Lagrange formula. And then third extension is constructed. Then successful binary extension, there's a binary extension, once again binary extension, two successful binary extension. Then we have the BT-BB structure is completed here. And Galois theory tells, if one wants to solve equation in terms of root operation, then the process is strongly limited. Only this processes. More than degree 5, this we cannot apply. Abel cells, there is no solution. General equation, we cannot solve root operation. Okay, that is so. Hence, we see that. Yeah, here we have observed in the evolution as B, T, B, B structure. B is many times appears, but only one time appearance of ternary extension, other than successive binary extension. This is a very important point. Professor Kellner has developed the ternary analysis, and so I think his attacking point is, I think, that's a very good one. Yeah? Okay, BTBB structure at first is binary extension, ternary extension as a binary, ternary, binary, and so on. BTBB. I think we need not to know explanation. We have seen that, yeah. In section one, I have we have decompose any evolution, decompose into successful period evolution. In this way, BTBB structure can give the decomposition and how old the reference evolution is. Huh? How old our universe? Baby or child, adult or old or scarcely die? Huh? Physics can answer this by satellite observations, theories, and 138 cross 10 power 8 years or so. Yeah, please try to find, decompose total evolution of the universe into period evolutions. The hint is finding, as I have told, only one time ternary extension appears. So the ternary extension, if we can find it, then we can find the one period. Huh? Here is a quark. This is the very early time of the second one is here baryon. Here is the ternary extension. And then next the atom comes. How about this? Please consider this. Okay, so quizzes remain to you. So I'm going to the complexity structure. Now is people's concerning of complex systems. Conway is the chaotic dynamics of Prigozhin is non-equilibrium statistic mechanics. Yeah, and Kaufman is chaotic dynamics. Mandelbrot is a fractal. The people start from the complex structure. I prefer after the construction of the BTBB structure, then successful binary extension happens and complex system is created. That is our idea. Then the most important checking point of complex structure is at the beginning of the evolution, always explosion happen, and the seeds and the matters are spread, and they make a random walk, simple random walk. Huh? But time is passing, then complex structure is created, then simple random walks is changed to be self-avoiding random walk. Huh? Dujan, N is 2. Oh no, sorry. Dujan is N is 2. Sorry. Dujan has introduced the concept of self-avoiding random walk. and he discussed polymers, and they are completely different for simple random walk particles and so on. So, okay, then so if we watch the distribution of galaxy, then we can obtain the universe is not young. And now it's become adult. Huh? So you see, when we want to be a baseball player, and like Otani, and then at first we start, then ooh, my technique is very high levels rapidly. Oh, I will be genius. I will be Otani. Huh? But 19 years old and so on. It's very difficult. So then they will uh, using a brain, so some technique constructed. That is a self-avoiding lining structure. So, but we see that the galaxy has a distribution of polynomial this power law distribution. So this universe is not young, rather or middle adult. Okay, that is so finish. How many minutes? Okay.
I don't know, so maybe a little more, so 8 minutes. Or let Krzysiek decide.
Finish? No, it's better.
No, as you want. So
okay, the 5 minutes.
Sure.
Okay, then next we are going to evolution of the universe.
Okay, thank you.
Yes, in this section we propose the basic problems and give our answer. But the problem is here flatness of the universe, flatness problems, extension problems, distribution of galaxy problems, dark matter and dark energy is here. But here extension, dark matter, omit the elementary particles. I think the people who are concerned elementary particles, that they include the dark matters of black holes and included there. I want to know that. Distribution galaxy, as I have told, that Kobe has also this almost uniform, but somewhere is an uniform part appears. Why? Uniformity comes from the Boltzmann principle. Huh? Now is the universe is the Big Bang and falling down, destroy distributions. Even fantastic shadow and castles become to ruin and sand. Yeah? So now we may imagine universe also now is going to sand and ruins, but some part is against this and void and as constructed. So from this point of view, our universe is not young. Here, I want to propose a question and finish this. Can we imagine the Big Bang or inflation of this university without ambient space? This is a very naive question. But people, books and cosmology cannot assert this explicitly. Here, without if we have ambient space, then we can extend. So, but some people do not agree the ambient space because this ambient universe cannot be observed. Yeah? But you see, when we watch the moon, then we can see the only one side, yeah? Huh? Then we cannot see the behind side. There is no behind side moon. Oh, it's nonsense. So we set the ambient space universe of this universe, which calls the dark universe. Then we can consider the Big Bang and inflation in the total university universe. So then we can automatically introduce black holes, dark matters, because there is a border. We have the border between this universe, a dark universe. Huh? Then we associate border the black holes, dark matters. Then the border we cannot see it, but border is create concept of the dark matters and so on. So we can analyze evolution of universe. Then we can get. So I think it's better to stop here. It's okay. No, 5 minutes more than past.
So
Huh?
if you want, you can continue. So yes, sure.
It's okay.
Sure.
But next speaker will come now.
No. So there is no next. Not Faber will continue, but
Professor Faber will continue right after you.
Moment. Then I propose. For example, inflation as a cosmologists insist on the causes of Big Bang, but as I have told, evolution starts always Big Bang explosion. You see, firework also this is a ball, boom, very beautiful flower. That's just now present, and later falling down. The pieces of burned iron and etc. Life of language also same, yeah. But there is no unclear the origin of the language or life things. So therefore our several entropic method can answer there exists exclusion for the evolution university because evolution is started with exclusion. And here we assume they make a simple random walk. Huh? Then we notice Einstein effect, constant effect of Einstein constant is contributes this inflation and simple random walks. Einstein forget this. No, he add here. Hence, we see that the extension of the universe is of exponential type, the simple random walk. So to the tension of the exponential order. Then following Goose and the Kato discussion, we can derive the flatness, horizontal problems. We can solve it. So not so serious. Okay, and so later also then here is the inflation extension as at the Big Bang time, but now continuously extend. But that is not strong at the Big Bang, but continuation. Yeah. Why? Why? The inflation decreases because of the phase change of evolution. Huh? So at first exponential order, as I have told, we want to be Otani, but young. Every morning, from morning to night, I make a training. Oh, but no, I cannot be Otani. And phase transition happening, how can survive USR playable games? Then simple random walk becomes self-avoiding random walk, and then it starts on the galaxy of polynomial degree exponential order. This is why this extension created by dark energy, some people say. And entropic, and that will be rather longer. So I omit here. And black hole. I want to here speak this. Huh? Oh yeah. I want to make a comment to dark matter and dark energy. Huh? People considers dark matter, dark energy independently. Huh? Some people is a professional on dark matter, and other people's dark energies. But here, I want to consider both in one hand. You see, we record the period evolution. Then here Big Bang started, and then some later here singularity appears. At first as a simple random walks, border is not so big one, but here is dark matter comes. Dark matter is created. Then singularity comes. Singularity appears. We assume that the singularity creates mass. If there is no singularity of this universe, I think there is no masses. So if the border is created by Goda field with dark matter, then in order to keep Boltzmann entropy, we have to supplementary entropy. Huh? We put here is dark energy. Huh? Some people put here is quittentance. Oh, 30 years ago, many people the quittentance, and recently, no, nobody talk about this. So, therefore, and then recently, yeah. So dark matters here answers the dark matter created on the border. At the same time, a joint Higgs boson are created. Now, do forget this. They surprise the dark energies, and then make us stabilities, compensation each other. So from this, we can propose the distribution of the matters and energy is the first energy of cosmology, dark energy, dark matter. Then I can propose this percentage. But some people suggest 40 and 70. I don't know if my thinking is true or not. So anyway, yeah. Here is a comment. And then some people consider introduce new particles, quittentance, that is not attractive but repulsive. Huh? That they are repulsive inside and uniformly flat, widespread. But if we assume that border is filled with matters, this is pulling to the border. From inside it is repulsive, but is attractive on the border. So we need not assume such one, yeah. So therefore, yeah, really I want to finish here. Then I want to going to the conclusion of entropy, our study. Our study is still not complete. not the details and not the exact calculations. So I want to know that the direction of our research is okay or not okay, and much more better thinking exists. I want to know that. So I want to further studies and entropic methods and the non-commutative Galois theories and the mixing and so on. Yeah. Thank you very much for your pay attention.
Thank you very much for a great talk, very interesting. So
No, great. No, great. You are,
it's a lot of topics, yes, also.
yeah. But
Um,
I want to discuss from Big Bang to language. Why language is not a language out of cosmology? Huh?
Yeah, Dr.
And
Jarek, do they specialize also in language theory? So you
no,
will
no,
have
no
occasion-
language. If the coding of information, data compression. So in language, I'm not specialized. So,
But still, it's a form of language at some point, you know.
huh?
Yes.
Encoding data and compression data is also like language processing from certain point of view. So anyway, Dr.
Oh.
Jarek
Yes,
Duda
yes.
is specialist in many fields.
Ah,
Information
okay.
theory.
Further, we'll discuss. Continue. Your
Sure.
interest, your talks is interest for me, but
Organize.
that's the professional discussions. I am amateur, and so secretly we privately we discuss. Then
Sure,
no
sure.
problem.
Sure. Are there any questions, comments? So maybe let me start. Do you have some mechanisms for this self-avoiding random walk?
Self-avoid random walk is simple. Usually, random step 1, step 2, step
Sure.
3, then coming to intersect some
Yes.
original point, but self-avoiding random walk does not intersect
Yes. So
himself.
it's natural for polymers.
Yeah, so
Polymers, yes.
Dujan has developed his theory on the basis of this fact.
But why do you see it important here? Because now you have the trajectory, so you change time. You cannot meet you because you are in different times. So you are doing the trajectory in space time. So why do you need mechanisms of self-avoidance?
In space time.
So the trajectory of particle is a polymer in space time. So it's a long time. It cannot meet itself.
Oh.
So it's not a polymer because time
You see,
changes.
but you see in a galaxy, if we make a computer simulation of galaxy, then appears the string structures and I think that therefore because of the string structures, they make a simple random walk. I think so. Power law distribution in the galaxy.
Couldn't you interpret self-intersection of paths like particle creation and annihilation, particle-antiparticle annihilation or creation? So if a path in space-time intersects, you can interpret it as a particle-antiparticle creation or annihilation.
So now you are extending to Feynman paths, Feynman
Yeah,
diagrams.
so, if you mentioned that it's evolution in time, so if you have the time evolution and the non-self intersection, then you mean that there are no particle creations and annihilations. So what's the reason why you ask for, Osamu, why are you asking for avoidance, self-avoidance of paths? The question. What is the reason I will assume this self-avoidance of self-intersections?
Intersection what? The Q and Q antiparticle?
Yes. Why are you suggesting that such self-avoiding of paths appear? Why do you need it?
Oh, really?
Sorry.
But my understanding is that the Q and the Q star is independently moves their self-avoiding random, simple random walk both.
Yeah.
Huh?
Mhm. And why do you need self-avoidance? What is the reason why you assume it?
Huh?
Why do you assume self-avoidance?
No. The quark and anti-quarks behave the simple random walk, just usual random walk.
Oh.
But making two combination of the sequence and crystals, then the situation is completely changes, and they make a self-avoiding random walk. That is the idea of Duchamp. Duchamp has established polymer physics on the basis of this fact.
Yes.
Nobel Prize, yeah.
Okay. Thanks.
But you see, physicists say that Q between Q and Q star, there is symmetry breaking. Huh? If completely symmetry exists, then meet once again photon is created and vanishes. But symmetry breaking appears because of that the universe is non-uniform and power of distribution. But it's unbelievable for me. If baby is born here, no? Then you say, no, when you adult, you get a good baseball player, or how old he dies. Can you say that? Huh? Only when baby is born here, Big Bang. Just symmetry breaking will not determine the distribution of galaxy. Huh? You understand what I mean?
Not completely.
Not physics, yeah. So at first I have told you, now in order to understand the evolution of the universe, we need not insist to physics. So that Badin, that his entropic method derives Einstein equation. Huh? Relativistic field theory can be included our entropic method. Huh? So, but our method have no technique to observation, satellite or rocket. So we have to ask physics to please give me a calculation, etc. So then when we want to restrict our observation to physics, then that is called physical evolution theory. If we want to restrict ourselves to language, this is the linguistic evolution theory. Then we can cut into separately, and professionals can contribute the detail and descriptions can be given. Yeah, you understand what I mean?
Thanks. Yes.